Okay, on page 3, this is the rest of my show here today. We're factoring polynomials. Completely factor and list all zeros. So I've got two different answers I've got to give here. We got to write the p over q's. There's a 1 here, so it's just plus or minus the factors of 16. We have to check Descartes' rule of signs. As we start checking with synthetic division, we look to see if we have upper or lower bounds, and we're hunting for zeros, so let's go. I'm looking for all of the factors of 16. They are negative 16, negative 8, negative 4, negative 2, negative 1, 1, 2, 4, 8, and 16. 1 times 16, 2 times 8, 4 times 4. That's all we got. Now I'm going to do my plus or minuses over here just to save room for synthetic division and factoring down here. Okay, for the positive real roots, we have 1 sign change, 2 sign change, 3 sign changes. It's 3 or it's 1. Can I go back for just a second? I had that same scenario up here on the last page, 3 or 1. And when I went to go 3 or 1, what happened is I got x equals 7. That was one positive, but I didn't get another one. See what I mean? This or 1 thing that we've been dealing with, it's either 3 positive numbers or it's one of them and a pair of complex zeros. They come in pairs. That's why we had to have this or situation in the first place. Okay, so with that logic, I'm either going to find one of these numbers that works, or I'm going to find 3 of these numbers that works. If only one of them works, that means the other 2 is a pair of complex zeros. Now for the negatives, I'm going to go f of negative x on the top. That x to the 4th will not change. This x to the 3rd will to plus 4x to the 3rd. This will be minus 16x and minus 16. There is no x squared term, so when I do synthetic division, I got to put a 0 in the middle of my work. Okay, looking at this, there's 1 sign change. So I have an x to the 4th. I'm going to have to find 2 of them with synthetic division, and then the rest I can find with factoring or the quadratic formula or completing the square. So there's definitely a negative one. Let's just try negative 4 and see what happens. I'm going to put negative 4 into this function. I have a 1 for x to the 4th. I have a negative 4 for x to the 3rd. Be very careful here that you don't just fall into patterns and ignore something. There's no x squared. I got to put a 0. And then a 16 for x, and then a negative 16. I'm going to try this negative 4 to see if it works. If it doesn't, I'm hoping it's a lower bound so I can cross off negative 4 and negative 8 and negative 16. Bring down the 1. Negative 4 times 1 is negative 4. Add these two, I get negative 8. Multiply, I get 32. Add those two, and I get 32. Okay, multiply 4 times, I got to use my calculator here. Negative 4 times 32 is negative 128. If you add 16 to negative 128, you get negative 112. Multiply negative 112 times negative 4, and you get 448. And when you add negative 16 and 448, you get 432. Well, clearly that's not a 0, so I can cross negative 4 off my list. But also, I go plus, minus, plus, minus, plus. Since these alternate and that was negative, I can also cross off negative 8 and negative 16. So, moving away from the large negative numbers, I'm going to try negative 2. So I have 1, negative 4, don't forget your 0, 16, and negative 16. When I go to solve this, I bring down the 1. Negative 2 times 1 is negative 2. Add these, I get negative 6. Negative 2 times negative 12, 6 is positive 12. 0 plus 12 is 12. Negative 2 times negative 12 is negative 24. 16 plus negative 24, 16 plus negative 24 is negative 8. Negative 2 times negative 8 is 16, and I found my negative 0. There's only one of them, so not only did I find that negative 2 is good, but I know that I don't have to try negative 1. Okay, I learned that this is x plus 2 times, since I divided, by a linear factor, and it was x to the 4th I started with. This is now 1x to the 3rd minus 6x squared plus 12x minus 8. I do not want to use all of these coefficients in synthetic division again. I want to use these now because I'm going to break this down further. I don't want to keep trying to break down x to the fourth with a linear factor because I just keep finding different x to the thirds. I want to break this guy down. And I now know I don't use any negatives. So I'm going to go with positives. I'm going to go over here and try 4, positive 4, but I'm going to use these coefficients. 1, negative 6, 12, negative 8. 1, negative 6, 12, negative 8. Don't use the originals again. So put a 0 down here. Bring down the 1, I get a 4. Add these, I get negative 2. Multiply, I get negative 8. Add these, and I get 4. Multiply, and I get 16. Add, and I get 8. Now, 4 doesn't work. 4 doesn't work, and 4 also is not an upper bound. Now, it kind of makes me want to think I should try 8 and I should try 16. But I'm not gonna. I want you to see something. I'm gonna put a 2 in and watch what happens. 1, negative 6, 12, and negative 8. I'm going to circle this because this is problematic for us. I know it's not an upper bound, and it's problematic. Okay, so let me draw a line under here and watch what happens. Bring down the 1, multiply, and I get a 2. Add, I get negative 4. Multiply, I get negative 8. Add, I get 4. Multiply, I get 8. I get a 0. 2 actually worked. So now I know I have x plus 2 from over here. I have x minus 2, and then I have these. It's going to be x squared minus 4x plus 4. X squared minus 4x plus 4. That actually factors. Look, I got x plus 2 times x minus 2 times 2 sets of parentheses. I need an x and an x. I don't want to go 1 and 4 because I can't add 1 and 4 and get 4, but I do want to go 2 and 2. They have to be the same sign, and I want to get minus 4x. It's minus 2, and it's minus 2. Look, what happened here is I had a multiplicity of 3. We can't make a mistake here with this upper bound theorem and assume that because it's not an upper bound, one of these definitely works. We cannot make that assumption. The upper bound theorem goes like this. If all of these are positive, this is an upper bound. You can get rid of things above it. The upper bound theorem does not say the same logic backwards. If they're not all positive, then something else has to be an upper bound is not, or a 0. That's not true. Okay? I know that's tricky, but that's why you take tough classes. Math classes teach you logic. The truth is, if I put in a positive number and they're all positive, it is an upper bound. I don't have to waste my time. You cannot make the assumption that since one is negative, one of these has to work. That's not what the upper bound theorem says. So in this case, I had multiplicity of 3. So if I wanted to graph this, when I go to graph it, it crosses in 2 places, at negative 2 and at positive 2. And at positive 2, 1, 2, 3, the multiplicity is 3, so it swooshes through. This is an x to the 4th. X to the 4th looks something like this, like a W maybe, or just a regular parabola. This one comes down here, and as it goes to go through, it swooshes through. There's a straight through and a swoosh through. So this is the factored version, and here are the zeros. X equals negative 2, and x equals 2, with a multiplicity of 3. Well, that one was tough. Look at this next one. X to the 4th, so I'm finding 4 zeros, and I have a 72. Look at all of the P over Qs. There's so many of them, I just typed them in for you. I didn't even want you to waste your time doing that. We have to find 4 complex zeros out of this thing. Let's check Descartes' rule of signs. I could have 1, 2, 3. So 3 or 1. I'm guaranteed to find 1 positive, real, 0. Okay, the negatives. This would be x to the 4th. If I put a negative in there, that would be plus 2x to the 3rd. If I put a negative in there, it will not change this, so it's plus x squared. If I put a negative in here, it becomes plus 18x. There's no place to put a negative in here, so it's minus 72. For the minuses, or the negative real zeros, I will find one of those as well. So I'm going to look through here and look through here to see I should find at least one here and at least one here. Now it's possible they could be irrational zeros, so like the square root of 2 or the negative square root of 2. But there's no way I'm going to do that to you in this kind of a problem. Okay? So here we go. I'm going to start with negative 8. I'm just going to pick something that's kind of in the middle. If it's a lower bound, I get to cross off all of these. So here we go. I get a 1x to the 4th. I get a negative 2x to the 3rd. I get a 1x squared. I get negative 18 for x and negative 72. I'm trying this negative 8 to see what happens. I bring down the 1. I multiply, I get negative 8. I add, I get negative 10. I multiply, I get positive 80. I add, I get 81. Now I got to multiply 8 times 81. Once these numbers start getting crazy big, negative 8 times 81 is negative 648. It's a clue that this is not going to be a 0. But look, I got pluses and pluses going on. This might be a lower bound. So I'm going to keep going. I'm going to take negative 18 and I'm going to add 600, negative 648, and I get negative 666. So I multiply that times negative 8. And when I multiply that times negative 8, I get 5,328. And if I subtract 72 from that, I get 5,256. Okay, that is definitely not a 0, so I can cross off negative 8. But look, I went plus, minus, plus, minus, plus. When I put a negative 0 in and they alternate, all of these are now off the table. I don't have to worry about trying them. Okay, so I'm going to try negative 4. Try negative 4. Now, unlike the last problem where we found something that was not an upper bound, here we found something that definitely is a lower bound. It meets the criteria, so I definitely can cancel all of them off. Negative 4, I'm going to try that one. 1, negative 2, 1, negative 18, negative 72. Maybe negative 4 will be my negative 0. Then I can get rid of all the negatives and move on to the positives. I bring down the 1, multiply, I get negative 4, add, I get negative 6, multiply, I get 24, add, I get 25, multiply, I get negative 100. These numbers are starting to get big. Add, I get negative 118. This isn't going to work, but let's see what happens. Negative 4 times negative 118 is 472, and when I add these, I get 400. I did not get a 0, so negative 4 doesn't work. But I go positive, negative, positive, negative, positive. Negative 6 isn't going to work either. This is a lower bound. So even though I've missed twice, I've definitely learned a lot. Let me try negative 2. I put in 1, negative 2, 1, negative 18, negative 72. Bring down the 1. Multiply, I get negative 2. Add, I get negative 4. Multiply, I get negative 6. Add, I get negative 5. Multiply, I get negative 10. Add, I get negative 28. Multiply 2. Did I do that right? I feel like I did something wrong. I did do something wrong. Negative 2 times negative 4 is not negative 6. That's negative 8. I'm so dumb. Negative 8 plus 1 is negative 7. Negative 2 times negative 7 is positive 14. That's not a negative 8. That's a positive 8. Good Lord. This is a 9. That's a negative 18. Sorry, this is just a hot mess right now. Negative 18 plus negative 18 is negative 36. And negative 2 times negative 36 is positive 72. I did actually get a 0. Oh, sorry about that. Negative 2 times negative 4. I don't know why I had so much of a problem with negative 2 times negative 4. That's just positive 8. These are 9. That's negative 18. That's negative 36. That's positive 72. That's a 0. Take my math degree away. I'm a hot mess. Okay, so it's x plus 2. And then what I get out of that is x to the 3rd, because I started with x to the 4th, minus 4x squared plus 9x minus 36. Okay, now I found my negative. There are no more negatives. I can cross off negative 1. I circle negative 2 and cross off negative 3. Let's go find a positive. So I'm going to try a 4. And I'm not going to use the original. I'm now using 1, negative 4, 9, and negative 36. 1, negative 4, 9, negative 36. When I put this 4 in, watch what happens. I get a 1, multiply, I get a 4. That's a 0. Multiply, I get a 0. That's a 9. Multiply, I get a 36. And I actually get my second 0 with my first try. Look at that. Now, when I put the 4 in, look what happened. Positive, 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 positive. I can use zeros as positives. So that means that is an upper bound. None of those would count. Doesn't matter to me anyway, because now this is an x to the second, and I have a different way to solve. I have x plus 2. I have x minus 4. That's not how you spell that. X minus 4. There we go. And then I go x squared plus 0x plus 9. I'm going to solve this over here on the side. X squared plus 9 equals 0. X squared equals negative 9. X equals plus or minus the square root of negative 9. X equals plus or minus 3i. So here are my factors. X plus 2. X minus 4. X minus 3i. X plus 3i. I'm supposed to find 4 of them. I found 4 of them. 2 are complex, 2 are real. I get x equals negative 2, x equals 4, x equals 3i, and x equals negative 3i. All of those are zeros. If you wanted to try it, you could put 3i in for x and multiply it out, and you would get 0. Or you could put 3i into synthetic division, and you would get a 0. I see that you don't believe me. I'm going to try it. Ready for this? Here we go. I'm going to put a 1, a negative 2, a 1, a negative 18, and a negative 72. And I'm going to put an imaginary number in for synthetic division. Bring down the 1, multiply, you get 3i. When you add, you get negative 2 plus 3i. Now I got to multiply. Are you kidding me? Okay. 3i times negative 2 plus 3i. You will not be asked to do this on the test. This is negative 6i, and this will be 9i squared. 9i squared. So isn't that minus 9? So this would be negative 6i minus 9. So I go negative 9 plus 6i. Oops, it's minus 6i. Dang it. Negative 6i minus 9. When I add this, negative 9 plus 1 is negative 8 minus 6i. Now I have to multiply again. At this point, don't you just kind of want to go, Larson, I trust you, it's a 0. I'm telling you, it works out, it's a 0. Okay, those of you who are nerds, you can finish that one on your own. We are going to switch to the next page, and we're going to do 2 more problems.